All right, so let's have a look at the exam. So first question says, let me go ahead. Ubaid, इन questions को separately यार upload कर देना है, question की statement के साथ. So first question of the exam, Q1 says that you have this inequality, which is n choose k is equal to n minus 1 choose k minus 1 plus n minus 1 choose k. ये आपने prove करनी है using counting argument without any algebra. Okay, so counting argument जो आपके होते हैं वो होते हैं of type just जो हमने set की form में किए हैं. Okay, you show that this is cardinality of a set, you also show that this is also cardinality of a set, और वो दोनों set की cardinalities बराबर हैं. Okay, so you start with, we know what this is, right? This is cardinality of a set which is equal to the number of, so it's equal to the number of ways k elements can be chosen from n elements, right? Okay, so let's do that. So आपके पास ये let's say elements है 1 2 3 4 up till n, और इसमें से the number of ways to choose k elements, okay, is equal to n choose k. अब हमने शो करना है कि the number of ways to choose k elements is also equal to this second part. Okay, let's see how that is. Okay, so another way, another technique कह लें इसको, I don't know, technique to choose k elements is to first fix one element. Okay, मैं एक element fix कर लेता हूँ, let's call it 1.
Yes, sir.
Okay, now so there are two possibilities. Regarding 1. Okay, एक possibility ये है कि you choose 1. Second possibility is not choose 1 whenever you are choosing k elements. Okay, if you choose 1, then the number of ways to choose k elements is k ये आपने pick कर लिया है. Okay, अब remaining elements में से you have to pick how many? K minus 1. Okay, so if you choose 1, this is the number of ways you can choose the rest of the elements. Okay, but if you don't choose 1, then you have to choose all the elements from the remaining elements. Okay, so since these two are two exclusive choices that you have, we know that n choose k is equal to n minus 1 choose k minus 1 plus n minus 1 choose k, and that's it. This completes the proof. Okay, so we sort of did a double counting on bijection, जिसमें हमने ये कहा कि n choose k is equal to this expression, which is equal to, again, choosing k elements from n elements. Are we good?
Yes, sir.
Okay. Let's move on to the next question. So in the next question, you are given a simple undirected graph on n vertices, and you need to show that a discrete bisector exists in a forest graph. Okay, so I define this discrete bisector to be so discrete bisector is a vertex that if I remove this vertex, तो बाकी जो आपके ग्राफ के कंपोनेंट्स बचे हैं उन सब का साइज would be, okay, sorry, strictly less than n over 2 plus 1. Yeah, okay, all right, and we need to show that that every forest graph contains at least one discrete bisector. Okay, let's have a look. So problem 2, that every forest graph contains a vertex v such that g minus v, let's define g minus v to be the graph that I get after removing the vertex v, contains no component of size more than or equal to n over 2 plus 1. Okay, इस size का नहीं होना चाहिए, इसे छोटा होना चाहिए. Okay, so first of all, let's say कि G is an arbitrary forest. Okay, if forest का मतलब ये है कि it's a graph which does not contain any cycle. Okay, it could be disconnected. So what you do is for if all connected components are already small. Okay, हो सकता है connected component पहले से ही small हो, then we are done.
Yes, sir.
Right? Otherwise, there can be only one component.
Yes, sir.
जिसका
जिसका
size,
साइज n/2 या उससे ग्रेटर हो.
हाँ, वन एक ही कंपोनेंट हो सकता है जिसका साइज n over 2
n/2 से
plus 1
ज्यादा.
के इक्वल हो या इससे बड़ा हो. ओके, क्योंकि दो नहीं हो सकते ना, दो आप इनको
Yes,
जमा
sir.
करेंगे तो
Equal
you
होगी
would get
क्या?
something more than n. Okay, so you would get n over 2 plus 1 plus n over 2 plus 1, which is equal to n plus 2. Okay, so you can't have this, you can have only one. So pick an arbitrary vertex, कोई भी एक vertex पकड़ लें. Let's call this component x. Okay, it's a big component, it contains more than this many vertices, more than or equal to this many vertices. Arbitrary vertex in x. If removing x, sorry, if x is, let me remove this, if sorry, arbitrary vertex का नाम नहीं रखा मैंने. Let's call this vertex, let me use, so for an arbitrary vertex x, if v is db, it's a discrete bisector, then we are done, right? Otherwise, there is a component in G minus V with more than or equal to n over 2 plus 1 vertices. Okay. अब so what is this? इसमें हो क्या रहा है? So you have an x component और उसमें एक vertex you picked V. Okay. इसके कुछ neighbors हैं. I don't know, हो सकता है इसका सिर्फ एक ही neighbor हो और उसके आपस में कुछ neighbors हैं. Okay. So if I remove V, then I get, for example, in this case, I get 3 components. Okay. If all of them are small, then we are done, right? But there is a possibility that one of them is big. Okay. Again, by the same logic, you can't have the possibility that 2 of them are big. Okay. So at most one of them is big. Let us walk towards that component. Okay. Pick a neighbor of V in big component um, as DB candidate and repeat. So for example, if this is the big component, तो फिर हम ये कहते हैं कि इस component में जो V का neighbor है इसको हम next DB candidate के तौर पे यूज करेंगे. Okay, but what we make sure is that जो remaining आपके पास components हैं, so what are we trying to make sure? We are trying to make sure that we walk away from V and we make sure that if I remove this new candidate vertex, which is the new, let's say call it V bar, तो फिर जो components create होंगे उसमें से एक V वाला component होगा. Okay, so we know that pick a neighbor, इस neighbor का नाम मैंने V bar लिखा हुआ है. Okay, pick a neighbor V bar of V in the big component as DB candidate. We know that G minus V bar अगर हम इस ग्राफ को देखें जिसमें हम ये इस वर्टेक्स को रिमूव करें, may contain a big component. Again, big component की definition ये है कि it contains at least n over 2 plus 1 vertices. Okay, so it contains big connected component, but it can't be the component that contains V. Okay, how do we know this? मैं इसके बारे में सिर्फ दो बातें करना चाहता हूँ and this will complete our proof. Okay, पहली बात तो ये है कि it can't be the component which contains V. Okay, and I want someone to answer this question. एक तो बात ये है. Okay, और दूसरी बात ये है कि it can't be okay, so it sorry मैं इसको remove कर देता हूँ. So it contains less vertices than a big component of G minus V. Okay, this will complete the proof. But why are these two things true?
Sir, because it is a forest in which there is only one path possible, sir, between every two vertices.
Yes.
And if we move to from V to one of its branch,
Yeah.
the rest of the branch wouldn't contain V.
Yeah. So the thing I'm asking is, okay. So let me make the same picture again. Okay. So I have a vertex V. Okay. और इसके neighborhood में कुछ है. Okay. Similarly. Okay. और इसके neighborhood में एक vertex है V bar. Okay. और उसके neighborhood में कुछ है. So on. Okay. So if I remove V, so I get this part as the big component. Okay. Now the question is, if I remove V bar, मैं इस तरफ चला गया हूँ. If I remove V bar, the connected component in G minus V bar can't be this component. जिसमें so it's not possible कि जो component जो V को contain कर रहा था, this is now the connected component which is big after removing V bar.
Because sir, we are disconnecting the only path between V and the other component. It is going
Okay.
to exist only one path.
um, so I'm still missing. So the thing is, देखो V bar को अगर मैं disconnect करता हूँ ना, remove करता हूँ, तो I get in this example I get three connected components. एक ये वाला, एक ये वाला और एक ये वाला. Okay. So the question is it possible that this is now the big component? And the answer is no, but I'm asking why no. Right? ये V बार के ये तीन नेबर्स है ना, एक V है, एक ये कुछ I don't know, V double bar है और ये एक U है. Okay. So you have three connected components, and one of them by assumption is a big component. The claim is it can't be the one which contains V. So again, this is true because हमने V के ऊपर खड़े होके ये कहा था कि the big component is the one which contains V bar, right? Which means this guy has a number of vertices n over 2 plus 1 at least. इससे ज़्यादा होंगी, इससे कम होंगी, कम नहीं होंगी. Okay? Which means कि जो remaining number of vertices हैं वो at most इतनी है. Okay? But this is less, right? This is smaller than what is required for it to make a big component. Okay, so it can't be the big component because पिछले episode में हमने ये कहा था कि V bar is a vertex in a big component. Okay, so there can't be enough vertices on the side of V to make it a big component. Okay, और दूसरी बात हम ये कह रहे हैं कि the big component now will contain less vertices than the big component when we were removing V. Okay, and that's true because अब जो नया big component है वो original big component का सब part है, उसमें से हमने V bar remove कर दिया है. Okay, so the number of vertices in the new big component is less. And that's sort of since, and this completes the proof by saying that since the number of vertices are in big component are decreasing, वही दो parts हम use करेंगे, and we are not creating any new big components, we will find a dB vertex by applying this process repeatedly. Okay, so this completes the proof कि हम हर step में we are decreasing the size of the big component, or big component, the new component is always a sub big component of the original component, which means at some point we will reach a vertex along this path. I don't know which one do you take here, but along the path we will reach a vertex that if we remove it, अब जो big component का size होगा वो इससे छोटा रह गया होगा. Okay.
Okay.
Any questions, people? All right. I'm sure you guys did it better than I did. Okay. So here's the part 3, which says that you have a sequence of trees on n vertices, and you need to show that there exist two vertices such that their diameter is equal.
Yes,
Okay.
sir.
So you have so problem or question 3, T1, T2, T3, Tn minus 1, I think, sequence of trees. contains two trees, at least two trees of equal diameter. I ask you guys to start with the definitions. The diameter of the definition of diameter is it's the
longest path.
longest
Path.
shortest path, right? Longest shortest path between a pair of vertices. Okay. So since these are trees, let's find out what's the longest path possible. Okay. So I know that diameter of each tree ti is at least 2. Okay, because one तो नहीं हो सकता. You start with the vertex u and then you have a neighbor v. अब v का कोई neighbor होगा कम से कम, right? या u का कोई नेबर होगा, राइट? ये दोनों आइसोलेटेड तो नहीं हो सकते. सो इफ v का कोई नेबर है तो लेट्स कॉल इट x. अब x can't be connected to u because it's a tree. You can't have a cycle. Okay, so the distance from u to x is 2. So diameter is at least 2. Okay, diameter can't be.
And at most n-1.
Yeah, and diameter is the second part as stored. The diameter is at at most n-1, or
इसकी एक और
वो,
approach थी सर.
which is the maximum diameter in any connected graph. Okay, if this is a connected graph, so two vertices are connected by going through all the rest of the vertices. Okay, बाकी सारी vertices से होके ही जा सकते हैं maximum, right? और इससे ज़्यादा हम क्या कर सकते हैं अगर वो connected है तो, right? सारी vertices होके जाएंगे तो you would get a path of length n-1. Okay, so we get let's list down the diameters. Let's call it d1, d2, d3, d4, or dn-1. So there are n-1 of them, and these are your pigeons. And here are your pigeonholes, and pigeonholes are the possible diameters. Okay, so they are 2, 3, so on, up till n-1. Okay, so there are n-1 pigeons and n-2 pigeonholes. This is the classic pigeonhole principle, which gives you that there exist two di d equal to dj, where I is not equal to j. Okay, so this means that there are two trees which contain which have the exact same diameter. क्या
सर ये इसकी ना एक और अप्रोच थी. हमने ना डीएसए में पढ़ा था कि ट्री का ना छोटेस्ट जो डायमीटर हो सकता है वो होता है 1 प्लस फ्लोर ऑफ log ऑफ 2 ऑफ n. वो बाइनरी ट्री का की फॉर्म में होता है. तो सर अगर हम
so that's not valid ना. देखो तुम्हारे पास if I pick this guy, so for example this, look at this graph, right? This is the n-1 vertices है आपके पास. Okay, sorry, n vertices, and then this is a graph, this is a star graph, right? This guy has diameter 2. Diameter of this guy is 2. अब क्या कह रहे हो?
सर ये सर ट्री की दो ब्रांचें नहीं होती सिर्फ.
मैंने जो आपको ट्री पढ़ाया है उसमें तो ऐसी कोई बात नहीं कि मैंने
हो सकती है मल्टीपल. ये 2 ब्रांचेस नहीं होती सर.
मैंने कभी कहा है आपको ट्री की 2 ब्रांचेस होती हैं?
सर हमने वो डीएफए में ट्री जितने ही पढ़े हैं 2 ब्रांचेस.
हाँ पकड़े फिर उनको यार.
ओके सर.
हाँ ऑलराइट. सो अगेन देखो ये बहुत सारे लोग ये गलतियां करते हैं, तो जस्ट कीप इट इन माइंड. अ ट्री इज, तो वो जो ब्रांच वाला चाइल्ड और पेरेंट वाला बात है, दैट्स नॉट द general concept. General concept is a tree is a graph which is connected and it's not cyclic. It does not contain any cycles. Okay. All right. So that's the question number 3, and we have last question. अब यहाँ पे देर बार मेरे ख्याल में मैंने मार्जिन रखा था लोगों के लिए to be creative. But let's see. So first part was whether a two regular graph contains a Ham cycle. So if it's a two regular graph, you could have um you could have this, right? You could have two disjoint cycles, right?
Yes,
And
sir.
this does not contain a Ham cycle, right? So this is purely false. All you needed was to write false and then give me this example. Every four regular graph is Eulerian. This is true, okay, by the Eulerian 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 condition जो हमने क्लास में पढ़ी है, okay? If every degree is even, so it must be an Eulerian graph. Okay? So second part is if G is equal to VE is planar, then number of edges is equal to on the order of V. This is true as well, right? Because हमने class में पढ़ा है कि the number of edges in a planar graph is less than or equal to 3 times the number of vertices minus 6. Okay, so definitely we know that number of edges is big O of number of vertices. KNM is always Hamiltonian. This is not true. This is false because you could have N to
Yes,
be,
sir.
for example, 3 and M to be 2, right? ये हमने actually class में example की है कि if the number of vertices on two sides is not same, then you can't have an Hamiltonian cycle in there, right? So this is clearly false. This was sort of this is actually true, okay? So I'm not sure if people got it,
और भी
but
हो सकता है सही है क्योंकि टू वर्टिसेस का जीरो रेगुलर ग्राफ सर वो नॉन होमोडैलियन होता है
yeah, so this is in general true. So इसीलिए मैं ये कह रहा था कि ingenuity मैंने यहाँ पे कुछ मार्जिन रखा था लोगों के करने के लिए. So if for example n is more than or equal to 3, I think मेरे ख्याल में this
ये कंडीशन
becomes
कोई नहीं क्रिएट की
true
सर
मेरे ख्याल में. So that was for ingenuity ना, इसीलिए मैंने ऊपर मेरे ख्याल में मैंने सिर्फ इस पार्ट के लिए यहाँ पे लिखा था कि extra credit would be given for exceptionally
ओके
well written arguments. खैर anyhow I'm gonna wait. अगर ये लोगों ने अगर किसी ने भी नहीं किया एग्जाम में तो probably give you as a homework question. Okay, so I'm not gonna give a solution for this now. Okay, well let me see, let me have a look at the exams अगर लोगों ने किया है तो that's wonderful and we'll discuss the solution in the next class. But if not, though, I'm gonna give this as a homework question. Okay. All right. Any questions, people?
Sir, one question right here.
Yeah.
Sir, the number of homeworks we expected were done already.
Oh yeah, we have. So I'm gonna give this as a bonus homework. Okay.
Okay.
अगर किसी ने नहीं किया तो I'm gonna give someone extra credit to do this.